Now we are going to compound gear trains. We have seen that the simple gear trains are generally used when the distance between the two shafts, that is driver shaft and the driven shaft, is more. So in between we use the idle gears. So this idle gear do not participate in the speed ratio, but it is just used to fill up the gap between the two shafts which are spaced apart at a larger distances. But many times what happen, we have to transfer the power from the driver shaft and the driven shaft, and the distance between two is very large, and apart from that we have to obtain a great speed reduction or speed magnification, we can say. uh, that is, speed ratio should be more. So in that case simple gear train does not solve our purpose, and then we have to use a compound gear train. Now what is called as a compound gear train? When when on a single shaft more than two gears are mounted, then that type of drive is called as a compound gear train. So in a compound gear train there are more than one gear shaft on a single shaft. As we have seen in a simple gear train, there is only one gear mounted on a one shaft. So but in compound gear train there may be a two gears mounted on the single shaft, and that's why it is called as a compound gear train. And these compound gear trains are generally used when we need to bridge the gap between the two shafts, that is driver shaft and the driven shaft, and apart from that we have to achieve a higher speed ratio or speed reduction or speed magnification. So in that case compound gear train is used. So just look at this particular arrangement. What we are having, we are having a first gear which is mounted on the shaft A, and this is the driver, and we have to transmit the power to the gear 6 which is the driven shaft and which is mounted on the shaft D. As the distance between this shaft A and shaft D is large, we introduce two compound gears in between. So on shaft B there are the two gears mounted. These are rigidly mounted on the shaft B, gear 2 and gear 3. So the speed of rotation of the gear 2 and the gear 3 will be same, while we are again having a shaft C on which the gear 4 and gear 5 are mounted. So this is called as a compound gear. Okay, now gear A is in engagement with the gear 2 and it will rotate the gear 2. As gear 2 will rotate, gear 3 will also rotate with the same RPM, and this gear 3 is in engagement with the gear 4. So it will drive the gear 4. Now as gear 4 will rotate, because of that, as gear 4 and gear 5 are mounted on the same shaft, gear 5 will also start rotating, and this gear 5 is in engagement with gear 6, that is the driven gear, and this gear 6 will start rotating. Okay, now we will see how to find out the speed ratio for the compound gear drive. So now suppose let n1 is the speed of the driving gear, speed of the driving gear first, and t1 is number of teeth on driving gear 1, right? Similarly n2, n3 up to n6 are the speed of respective gears 2, 3 and up to 6. Similarly T2, T3 up to T6 is number of teeth on the respective gear that is gear 2, 3 up to 6. So we will first consider gear 1 and 2 as they are in engagement with each other. So for this, the speed ratio we can write down n1 by n2 is equal to t2 by t1. Similarly for gear 3 and 4, the speed ratio can be written as n3 by n4 is equal to t4 by t3. And for gear 5 and 6, as they are in engagement with each other, we can write down n5 by n6 is equal to t6 by t5. Now to get the speed ratio for compound gear drive, speed ratio of compound gear drive multiplying equation 1, 2 and 3, that is we can write down n1 by n2 multiplied by n3 by n4 multiplied by n5 by n6 is equal to t2 by t1 multiplied by t4 by t3 multiplied by t6 by t5. Now as we know, gear 2 and gear 3 are mounted on the same shaft. Similarly, gear 4 and gear 5 are mounted on the same shaft. So speed of gear 2 and speed of gear 3, that is n2 n3 will be equal and n4 n5 will be equal. That's why we can cut this term. n2 is equal to n3 and n4 is equal to n5. So we can say speed ratio, that is n1 divided by n6 is equal to t2 multiplied by t4 multiplied by t6 divided by t1 multiplied by t3 multiplied by t5, right? So this is our speed ratio. This is the speed ratio. If we observe this term, we came to know that is this is t2 t4 t6. This is nothing but the number of teeth on driving shaft, number of the t2 t4 t6, this is nothing but the number of teeth on the driven gears, and t1 t3 t5, these are nothing but the number of teeth on the driver gears. So from this speed ratio we can say speed ratio is equal to speed of the first driver divided speed of the last driven or follower, that is n1 by n6. Speed ratio is speed of the first driver divided by speed of the last driven or follower, and it's equal to product of the number of teeth on the drivens, that is follower, divided by product of number of teeth on the drivers. Similarly, as we know, train value, that is a reciprocal of the speed ratio, train value is equal to speed of the last driven or follower divided by speed of the first driver, and this is equal to product of the number of teeth on the drivers divided by product on number of teeth on the driven. So this compound gear drives, are having following advantages. Advantages are that this compound gear drives by using these compound gear drives, a much larger speed reduction from the first shaft to the last shaft can be obtained with the small gears. Means the whatever the speed reduction which we are going to obtain, that will be far better with this compound gear drives, and that is the biggest advantage of this compound gear drives. I will show you how this compound gear drives look like. So this is a compound gear drive, a gear, driver gear, and in between you can see there are the two gears mounted on the same shaft. One is smaller and another is bigger, and the power is being transmitted.